Hi everybody, welcome back to Advanced Algebra 2. Today we are going to be working on lesson 5-4, how to solve radical equations. If you're following along in your workbook, it's on page 242, page 242. So if you look on page 242, that's where we are going to be taking notes today. Our essential question for this lesson is how can you solve equations that include radicals or rational exponents? So all of our equations today are going to look like 3x plus the square root of 4x minus 1 equals 3. They'll have at least one radical involved in the equation. So we're going to look at how do I solve for the x. All right, so I've got some steps that you're going to follow whenever you're doing this. First step is you're going to isolate the radical term. Sometimes you have one radical term, other times you don't. But we're going to start off with just one. So you'll isolate the radical term. You'll square both sides to remove the radical, solve the equation, and then you'll have to eliminate something called an extraneous solution. And those will pop up in today's lesson as well. An extraneous solution is a solution of an equation that's derived from the original equation, but it is not a solution to the original equation. So extraneous solutions are solutions that you get whenever you do everything algebraically correct, but your answer does not make the original equation true. So we will encounter some extraneous solutions today. All right, so let's start with our first example. Go to example 1. We're going to solve this radical equation, and we're going to follow those steps. So I've got the square root of x minus 2 plus 3 equals 5. So remember my first step was to isolate the radical. So my radical term is x minus 2. So I want to isolate that and get it all by itself. So to do that, I need to subtract the 3 on both sides. So that's going to give me the radical equation, the square root of x minus 2 equals 2. So once the radical is isolated, then step 2, on the previous slide, it said square both sides, but I'm going to write raise both sides to a power. Because if you have a square root, yes, you will square both sides because squaring undoes the square root. But if you have a cube root, then you'll need to cube both sides. So it just depends on whatever root you have is the power that you'll raise it to. So whenever you square a square root, you're undoing that operation. So on the left side, you'll just be left with x minus 2 equals, and then 2 squared is 4. So to get my answer, add the 2 to both sides. I get that x equals 6. So I just solved the equation. I got my answer, x equals 6. But now I need to make sure that I don't have any extraneous solutions. So to eliminate extraneous solutions, what I do is I go to my original equation and I substitute in what I got for x, and I see if I have a true statement. So the square root of 6 minus 2 plus 3, does that equal 5? So I am using my original equation and substituting in the 6 for the x. Well, 6 minus 2 is 4, so the left side would be the square root of 4 plus 3. Does that equal 5? The square root of 4 is 2. Does 2 plus 3 equal 5? Yes, it does. So that means 6 is not extraneous. 6 is an actual solution. So I will circle it. Let's try part B. Here I have a cubed root. See, I told you you'd have some cube roots as well. All right, I have a cubed root. The radical expression is already isolated. So now it's time for me to raise both sides to a power. So if I have a cube root, then I'm going to cube both sides. So the cubed root of something cubed, undoes that root. So on the left side, I'm left with x minus 1 equals 2 to the third power is 8. Then I'll add 1 to both sides. And it looks like my answer is 9, but I just need to make sure that 9 is not extraneous. So I'm going to go back to my original equation. I'm going to substitute 9 in for the x. So the cubed root of 9 minus 1, is that equal to 2? Let's check. That would be the cubed root of 8. Is that equal to 2? Yes, it is. So 9 is not extraneous. 9 is an actual solution. Now if we look at example 2 asks us to rewrite a formula. So we'll be working with formulas, and especially in your science classes, you'll find that whenever you're given a formula, sometimes you need to solve for the other variable that's in the formula. So sometimes you need to rearrange the formula, which is what they're asking for here. So let's read the problem. The speed of a vehicle v in relation to its stopping distance d is represented by the equation v equals 3.57 times the square root of d. What is the equation for the stopping distance in terms of the vehicle's speed? I'm going to underline that part because that's what we're asked to do. So what's the equation for the stopping distance? Well, stopping distance is d in terms of the vehicle's speed, and they said speed was v. So I write d with the parentheses v. You read it out loud, d of v. That means distance in terms of v. And you do see this notation quite a bit in pre-cal and in calculus, so you do want to make sure you understand what it means. Distance in terms of v. So what that means is d of v, you'll have a formula, blah, 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 formula, and then a v will be in there somewhere in the formula. So the d is on the equal side, and then the v is within the formula. So that means I need to take this formula v equals 3.57 times the square root of d and solve it for d. So I need to, first of all, isolate the square root. So if 3.57 is being multiplied by the square root, I'm going to divide both sides by 3.57. So now I have v over 3.57 equals the square root of d. So then, since I have the square root, I can square both sides to undo that square root. So when you square, cancels out the square root. So on the right side, I'll have d. On the left side, when you square a fraction, you square the numerator and you square the denominator. So I'm going to grab my calculator and type in 3.57 squared. So 12.7449. So there's my formula. You also might see it written in another class like d of v. So the stopping distance in terms of the speed would be v squared over 12.7449. You might see it in either form. But this formula would be handy if you're solving, if you have the speed and you want to know the stopping distance. The other formula is handy if you have the stopping distance and you want the speed. Now, if you're good at algebra, it really doesn't matter, but sometimes you just might want the formula solved for one variable instead of the other. So let's move on to example 3. This time, I promise we're going to have an extraneous solution. So here we have another example. We're trying to solve for a variable. So I'm going to follow the steps that were earlier here where we isolate the radical term. Then we're going to square both sides and try to solve. So let me find where we were again. Okay, so it looks like the radical is already isolated. So now I'm going to raise both sides to a power. Since it's a square root, I'm going to square both sides. So the left side, x squared. The right side, I'm squaring a radical. So I'm just left with 7x plus 8. And now I want to try to solve. But I notice, my highlighter here, I notice that I have an x squared. And x squared indicates that I have a quadratic equation. Since it's quadratic, that means I need to solve it using those quadratic equation solving methods. So the methods for solving a quadratic equation are factoring, quadratic formula, completing the square, and taking square roots. But I can't take square roots because I have an x squared and x, so that's not an option. So I've got these other three options that are perfectly fine. I'm going to try factoring. I always try factoring first because it is faster. So set it equal, but to try factoring or quadratic formula, you do have to make sure that it's set equal to 0 first. So I'm going to subtract the 7x on both sides, and I'm also going to subtract the 8 because I like to keep the x squared positive. And I'm actually going to come over to the right side so I have more room. All right, so that means on the left side I have x squared minus 7x minus 8 equals 0. To factor it, first, to get the x squared, I can do x times x. To get negative 8, I have a couple of options. I could do 1 times 8 or 2 times 4. Let's try 1 times 8. Because whatever I choose, this product and that product have to combine to be negative 7. So let's see, 1 times x is 1x, 8 times x is 8x. If I keep the 8 negative and the 1 positive, that will give me a negative 7. So I have a plus 1 here, minus 1 there. Let me erase the scratch work for figuring out my factoring. And then always, 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 because we're solving, bring down the equal 0. Then set each factor equal to 0 because we can apply the 0 product property. So I get x equals negative 1 and x equals 8. So it looks like I have two solutions, but I still need to check for extraneous solutions. So I do that by taking, kind of wrote over it, by taking the original equation and substituting in negative 1, and then I'll substitute in 8. So when I substitute in, let's check x equals negative 1. Negative 1, is that equal to the square root of 7 times negative 1 plus 8? Again, I'm substituting it into the original equation. So is negative 1 equal to the square root negative 7 plus 8? So is negative 1 equal to the square root of 1? No. Because whenever I just have this expression, they're asking me, well, this is the positive square root. So no, this is not true. So that means x equals negative 1 is extraneous. And we show that by putting an x through the answer we found. Don't erase it. I still want to see that you found the extraneous solution, but I also want to see you put an x through it so I know that you found it algebraically, but it doesn't make the original problem true. So write it down, but then put an x through it. Okay, now let's check x equals 8. Again, go back to the original problem, put 8 in for each x. 8 equals the square root of 7 times 8 plus 8. Is that true? Let's see, 7 times 8 is 56 plus 8. So is positive 8 equal to the square root of 64? Yes, it is. Positive 8 is equal to the positive square root of 64. So 8 does equal 8. So that means 8 is a true solution. It is not extraneous. part B is also similar. So let's look at part B as well. It's similar, but it's also very, very different. The radical is already isolated, so I am going to square both sides because it is a square root. On the right side, the radical cancels out, so I have equals x plus 2. On the left side, I need to square the quantity x plus 2. There are two terms here. I'm squaring the whole quantity, not each one individually. So because I'm squaring this entire quantity, I need to multiply x plus 2 times x plus 2. So square it. So then multiply that out. X times x is x squared plus 2x plus another 2x plus 4 equals x plus 2. If I combine like terms on the left, x squared plus 4x plus 4 equals x plus 2. I can subtract the x on both sides. X squared plus, I'm minusing x. I'm going to subtract the 2. So x squared plus 3x plus 2 equals 0. Now let's try to factor. Let's see, to get x squared, I can do x times x. To get 2, I can do 2 times 1. And then I just want to make sure that I'm getting 3x from this product and that product. So 2 times x is 2x. X times 1 is 1x. If you add them, you will get 3x. So make them both positive. All right, then I can solve by setting each factor equal to 0. So x equals -2 and x equals -1. Again, it looks like I have 2 solutions to this problem, but I still need to check for extraneous solutions. So to do that, I go back to my original equation. Let's see, I want to check x equals -2 first. So I'm going to substitute in -2 for each x. So that means I'll have -2 plus 2. Is that equal to the square root of -2 plus 2? Well, -2 plus 2 is 0. Is 0 equal to the square root of 0? Yes, that's true. So x equals -2 is a solution. Yay! All right, now let's check x equals -1. So go back to my original equation. Right here, I'm going to substitute in -1 for each x. So let's see, is -1 plus 2 equal to the square root of -1 plus 2? -1 plus 2 is 1. Is that equal to the square root of 1? Yes, it is. That's also true. So we actually have 2 answers here. So there's 2 answers. It's possible that both answers would be true solutions. It's possible that both answers would be extraneous. If both answers are extraneous, then you would select no solution. So now let's look at example 4. Example 4, we're going to solve this equation that has rational exponents. So you might think, oh my goodness, this looks totally different. But remember that rational exponents are radicals. They are radical expressions. So we're going to treat them just like a radical expression. So the radical expression that needs to be isolated is this right here. So I'm going to isolate this radical expression by adding 14 to both sides. So now I have x squared minus 3x minus 6 to the 3/2 power equals, let's see, negative 6 plus 14 is 8. All right, so here I need to raise both sides to a power. So if it was a square root, I would raise it to the second power. If it was a cubed root, I would raise it to the third power. But this is actually a square root that's been cubed. So what I'm going to do is I am going to raise it to the reciprocal power. Raise it to the reciprocal power. Because the reciprocal means you take the fraction and you flip it. So the reciprocal of 3/2 would be 2/3. So we're going to raise both sides to the 2/3 power. What that does is you have a power to a power, and you multiply. 3/2 times 2/3 is 1. So that cancels out the exponents. So then I have x squared minus 3x minus 6 equals, now 8 to the 2/3 power would be the cubed root of 8, which is 2, and 2 squared is 4. Now I have another quadratic equation. I'm going to come over here, but before I do, I'm going to set it equal to 0 so that I can try to factor it. So subtract 4 on both sides. So then I'll have x squared minus 3x minus 10 equals 0. So then if I try to factor, I'll have an x and an x. Two numbers that multiply to be 10. I've got 1 and 10, 5 and 2. I'm going to try 5 and 2. Again, I want to make sure that this product plus that product is going to be negative 3. So I've got 5x, 2x. If I make the 2 positive and the 5 negative, that will give me negative 3. So minus plus here. I'll move the microphone closer because they're mowing the yard outside. And I don't know if you can hear that or not, but it is super loud. Okay, so the microphone's closer to my face now. Okay. So set each factor equal to 0. X minus 5 equals 0. X plus 2 equals 0. Let's try to not let those be highlighted more. So then x would be 5 and x would be negative 2. But again, you got to check for extraneous solutions. So first I'm going to check x equals 5. Go back here, going to substitute in 5 for each x. So 5 squared minus 3 times 5 minus 6, all raised to the 3/2 power minus 14. I want to see if that equals negative 6. So I'm grabbing my calculator. I'm going to type this in. It does. It equals negative 6. So x equals 5 is a true solution. Now let's check x equals negative 2. So I'm going to take this original equation again. Instead of 5, I'm going to substitute negative 2 in for each x. So negative 2, make sure you put that in parentheses before you square it. Minus 3 times negative 2, minus 6 to the 3/2, minus 14. I want to see if that equals negative 6. So grab my calculator again. Does that equal negative 6? Okay, so let's see. 4 plus 12 minus 6 to the 3/2 minus 14. And it does. We get negative 6 equals negative 6. So x equals 2 is also an answer. So I have two solutions. There's no extraneous ones on this one. For part B, here I have two sets of binomials. I also have the first one's raised to the second power. The second one is raised to the 5/2 power. So let's see, I've got a fraction right here, so I'm going to raise both sides to the reciprocal. So the reciprocal of 5/2 would be 2/5. So I'm going to raise both sides. See what that does. Okay, on the right side, that cancels out. I'm left with x minus 10 equals. Now, what happens if I do x plus 8? 2 to the 2/5 would be 4/5. I still have a fraction. So, what can I do? So, I'm pretty sure that this problem is a typo because if you keep trying to, if you raise it to at least a typo for this level of math class. So if you raise both sides to the 2/5, it'll cancel out on the right side, but then you're left, so you've got x minus 10 here, but then you have x plus 8 raised to the 4/5. Then if you try to raise both sides to 5/4, you end up in a cycle that never seems to end. And then if you try to solve this out the long way, you end up expanding a binomial to the 4th power, and it's really long. But the answer for this specific problem is about 27.31, which, whatever. Okay, so we're going to call that a typo. I also double checked all your homework problems and made sure nothing was on there like this. So we're going to call this problem a typo, but I am going to change it to something that's going to match more like what you have. So you'll have something more like this, more like, oh, that's a highlighter. There we go. More like x squared minus x minus 74 all raised to the 3/4 minus 6 equals 2. So we're just going to mark off part B, and we're going to do this problem instead, because this matches more of what you need to be able to do at this level. So add 6 to both sides, because I'm trying to isolate the expression. So x squared minus x minus 74 equals 8. And this whole thing is raised to the 3/4 power. Okay, I want to try to get rid of the radical, so I'm going to raise both sides to the reciprocal power, raise both sides to the 3/4. Not 3/4, 4/3. Reciprocal of 3/4 would be 4/3. So when you raise the left side to the 4/3, it cancels out the exponent. You're left with x squared minus x minus 74 equals, the cubed root of 8 is 2, and then 2 to the 4th is 16. So then subtract the 16 on both sides. We have x squared minus x, let's see, 16, 74, minus 90 equals 0, because it's quadratic, so I set it equal to 0 to solve. So let me solve. Have x and x. To get 90, I can do 9 times 10. Make the 10 negative, the 9 positive. X plus 9 equals 0. X minus 10 equals 0. X would be negative 9, and x would be positive 10. And finally, let's talk how to solve an equation with two radicals. So example 5. So I've got two radicals. Well, if you look earlier at our very first set of steps where you have to isolate a radical term, if there's more than one, you're going to pick one to isolate. Then you'll square both sides to remove one radical, but then you'll have to go back and do step 1 because you'll still have one radical left. So we're going to isolate one, square both sides, but then we'll have to repeat steps 1 and 2 again before we can get to our final solution. So back to example 5. All right, so I'm going to pick one to isolate. I'm going to pick the larger one. So I'm going to isolate x, the square root of x plus 4, by adding the square root of 3x to both sides. So that means I have the equation the square root of x plus 4 equals the square root of 3x minus 2. So then I've isolated this radical. Now I can square both sides. On the left side, when you square both sides, the radical cancels out, and you're just left with x plus 4. On the right side, though, I'm squaring the entire quantity, and it's separated by a minus. So I need to make sure that I multiply the square root of 3x minus 2 times the square root of 3x minus 2. I need to multiply those two things together. So distribute. The square root of 3x times the square root of 3x is the square root of 9x squared minus 2 square root of 3x minus another 2 square root of 3x, and then negative 2 times negative 2 is plus 4. Then I'll bring down the left side. All right. Now the square root of 9x squared, the square root of 9 is 3, the square root of x squared is x. So I'm going to change this part to 3x. Then I also have like terms right here. So negative 2 square root of 3x minus another 2 square root of 3x is negative 4 square root of 3x. So I'll take all this information, start up here, start in blue now. So the left side is going to be x plus 4. The right side, 3x minus 4 times the square root of 3x plus 4. So I isolated squared, and now I still have another radical. So this time I'm going to isolate this radical expression. Actually, not the 4. I'm not going to include the 4. Just the square root of 3. So to get there, I'm going to subtract 4 on both sides from the like terms. I'm going to subtract the 3x on both sides from the like terms. X minus 3x is negative 2x. 4 minus 4 is 0, equals negative 4 times the square root of 3x. Now I still need to isolate this radical term, so I'm going to divide both sides by negative 4. So negative 2 divided by negative 4 is 1/2. So I have x over 2 equals the square root of 3x. Okay? Then I can square both sides. When you square a fraction, you square the top, you square the bottom. So x squared over 4 equals 3x. I can multiply both sides by 4 to get that 4 out of the denominator. So x squared equals 12x. And it's quadratic, so I want to set it equal to 0. X squared minus 12x equals 0. I set it equal to 0 by subtracting 12x on both sides. Now I need more space. Since it's quadratic, I want to try to factor. There is a common factor of x. So x times x minus 12 equals 0. Set each factor equal to 0. X equals 0. X minus 12 equals 0. So I have one answer, x equals 0. Add 12 to both sides, x equals 12. Woo, that was a lot of work to get two answers. However, it does say check for extraneous solutions. So I'm going to substitute in 0 first. and see if I get a true statement. So where do I'll just scroll down. I got more space down at the bottom. So if I put 0 into the original equation here, that would be the square root, draw a line here, the square root of 0 plus 4 minus the square root of 3 times 0. Is that the same as negative 2? That would be the square root of 4 minus the square root of 0. Is that equal to negative 2? Well, positive square root of 4 is 2. 2 does not equal negative 2. X equals 0 is extraneous, so I put an X through it. Okay? Now, let's check X equals 12. I'm going to take the original equation. I'm going to put 12 in for X right here, and another 12 in for X right there. So the square root of 12 plus 4 minus the square root of 3 times 12. We want to see if that equals negative 2. So that would be the square root of 16 minus the square root of 36. Square root of 16 is 4. Square root of 36 is 6. 4 minus 6 is negative 2. Okay, so we do have one solution here. X equals 12.